Hi friends, welcome back. Today we are going to discuss the types of functions. Already in the previous video we have discussed what is meant by a function, how to find the domain and range of a function. Now we will classify the functions. So the main classification is into one-to-one, one-to-one and many-to-one. Many-one. One-one or one-to-one and many-to-one. Second type of classification is on-to and into. On-to and into. Now we will see what is meant by a one-to-one function and how it differs from a many-to-one function. As the name indicates, one-to-one means there is a one-to-one correspondence between the domain and the range. That means the domain elements, the elements of the domain are attached with single element of the codomain or the range. So one-to-one correspondence. And many-to-one means, as the name indicates, many elements of the domain are attached with a single element of the range. So if we draw the arrow diagram for a one-to-one function, so here many elements are in the domain and this is the codomain, and if it is a one-to-one function, then each element of the range has a single pre-image in the domain. So the elements of the range has a single pre-image in the domain. Then it is a one-to-one function. Otherwise, that means if many elements of the domain are attached with a single element of the codomain or range, then it is known as a many-to-one function. So like this. So here this element has two pre-images. So minimum one element of the range must have more than one pre-image in the domain. Then the function is known as many-to-one. So it is very easy to remember because the name indicates what is the speciality of the function. One-to-one correspondence, that is a one-to-one function. Many-to-one correspondence, that is a many-to-one function. Now, if a function is given without drawing the arrow marks or without drawing the arrow diagram or taking the examples and all, how do we show that whether or how do we check that whether it is a one-to-one function or a many-to-one function? For example, f of x is equal to 2x plus 3. F of x is equal to 2x plus 3. This is the function, suppose, and the function f is defined from z to z, the set of integers. Now, whether this function is a one-to-one function or a many-to-one function? If it is a one-to-one function, then f of x1 is equal to f of x2 implies x1 must be equal to x2. F of x1 equal to f of x2. What's the meaning of f of x1 is equal to f of x2? The image of two elements are same. If the images are same, then the elements must be same. So f of x1 equal to f of x2 implies x1 equal to x2. If we can prove that f of x1 equal to f of x2 implies x1 equal to x2, then the function will be one-to-one. Let's check. Like f of x is 2x plus 3. So f of x1 will be 2x1 plus 3 is equal to f of x2 will be 2x2 plus 3. So 3 cancel, we get 2x1 is equal to 2x2. That means x1 is equal to x2. So in this example, that is f of x is equal to 2x plus 3, it is a one-to-one function. Now many to one means many elements of the domain are attached with a single element of the range. So if you take the same example, instead of x as x square, that is f of x is equal to 2x square plus 3. 2x square plus 3. Now just check, f of x1 is equal to f of x2, implies 2x1 square plus 3 is equal to 2x2 square plus 3. Again 3 cancel, you get 2x1 square is equal to 2x2 square. That means x1 square is equal to x2 square. That implies x1 is equal to plus or minus x2. So x1 may not be equal to x2 always, because x1 square is equal to x2 square. That implies x1 is equal to plus or minus x2. So if here is minus 1 and this is plus 1, both minus 1 and plus 1 will be having the same image in the range, because x1 is equal to minus x2 is also possible. So the function is 2x square plus 3. So for plus 1, the image will be 2 into 1 square plus 3, that is 5. And minus 1 also, it will be 2 into minus 1 square plus 3, that is again 2 plus 3 is equal to 5. So the function will be many to 1. So this is the condition for checking whether the function is 1 to 1 or many to 1. F of x1 equal to f of x2 implies x1 is equal to x2, then it is 1 to 1. Otherwise, that means x1 is not equal to x2, then it is many to 1. Now the second is onto and into. Onto function means very easy to understand. Range is equal to the codomain. If the range of the function is equal to the codomain, that means no extra elements in the codomain that are not attached with any elements of the domain, or all the elements of the codomain have pre-images in the domain. In that case, the function is known as onto. Otherwise means if range is not equal to the codomain, then it is known as into. So for an onto function, whatever elements are there in the codomain, each and every element must have a pre-image in the domain. So like this. In this case, it is known as an onto function. If there are extra elements in the codomain that are not attached with any element of the domain, here in this arrow diagram, there are two more elements in the codomain that are not attached with the elements of the domain. So in this case, this is an into function. So onto and into function. Now again, without taking the example or without drawing the arrow diagram, how do we show that whether it is an onto function or an into function? The definition itself shows, that means onto means range is equal to the codomain. Now if the function is defined, again the same example, let us take z to z. Function is defined on the set of integers, and take this condition, f of x is equal to 2x plus 3. Now check whether it is an onto function or an into function. So y is equal to 2x plus 3. Now this is the codomain, z is the codomain. What is the range? Y is equal to 2x plus 3 means x will be equal to y minus 3 divided by 2, that is f inverse y is equal to y minus 3 divided by 2. So all the values of y are possible. So here the range is equal to the same thing, that means z. So here range will be equal to the same codomain. Therefore we can say that the function is an onto function. Now the second one, this example take. F of x is equal to 2x square plus 3. Check whether it is an onto function or an into function. Second case, if we take y is equal to the same thing, I am taking 2x square plus 3. So we can say that y minus 3 divided by 2 is equal to x square, or x is equal to root of y minus 3 divided by 2. Now when it is a square root function, we know that y minus 3 must be greater than or equal to 0, that is y must be greater than or equal to 3. So the range is 3 to infinity. 3 to infinity. Only the integers, not the real numbers. So 3, 4 here we can say that because I have taken it as z. So we can say that 3, 4, 5, 6 etc. More than 3 only. But here the codomain is all the integers. Or otherwise also we can check that because it is 2x square plus 3. We will be getting the values because the minimum value of x square is 0. So 2 times 0 plus 3. So the minimum value of the range will be 3 only. So there will be extra elements in the range or in the codomain that are not attached with the elements of the domain. Therefore it will be an into function. So this is the classification as one-to-one, many-to-one, onto and into. This one-to-one is also known as injective function. Onto is also known as surjective function. A function which is one-to-one and onto, or we can say injective and surjective, is known as a bijective function. A function which is one-to-one and onto, or injective and surjective, is known as a bijective function. And all bijective functions are invertible. That we will check in the next video. How do we say that these bijective functions are invertible?